Hi everyone, I'm Sleepless Scientist. Tonight we're stepping back, way back, to a time when the Earth didn't glisten blue from space, didn't shimmer with waves, didn't rain or mist or drip. Imagine Earth before the first puddle. A planet spinning silently in darkness, bone dry and angry. That's where we begin, a world without water. Hard to picture, right? A thirsty Earth. But it existed. And the story of how we went from that to oceans and rivers and bathtubs is longer, stranger, and more beautiful than you probably imagined. I'd love to know where in the world you're listening from and what time it is for you. Let me know in the comments below. I'm always curious where these quiet little science stories are drifting to, and if this video helped you while you were there. And just between us, every time I imagine someone dozing off to science instead of stress, it makes the storytelling worth it. Let's begin. You shuffle to the edge of time, not in your slippers, but in your mind, swaddled in warmth, eyes half closed. Earth is young. Around 4.5 billion years ago, a fresh molten world has just formed from the leftovers of a messy solar system. Space is still cluttered with flying rocks, heat waves, chaos and dust. No oceans here, no lakes, no clouds, not even steam, just lava. You drift over a planet that's red-hot volcanic spinning like a half-cooked pancake. The sky is black, except when lit up by constant asteroid impacts. The air, if you could call it that, is a churning soup of carbon dioxide, methane, hydrogen sulfide, a toxic cocktail that would melt your eyebrows. And yet, this is where the story of water begins. See, when Earth first formed, it wasn't built with water. Not much anyway. The building blocks, the rocky bits that clumped together in the sun's leftover disk, were dry, scorched things. The inner solar system where Earth orbits was too hot for ice to form. That's why some scientists believe water had to come from elsewhere. A cosmic gift, or depending on your perspective, a cosmic accident. But before we get to that, you hover over the young Earth, watching as volcanoes erupt like pimples on a teen's face. They belch gases into the sky, steam, carbon dioxide, nitrogen. As Earth cools, some of that steam condenses and settles into low places. But it's not water yet. Not really. It's still too hot. The surface is lava ocean hot. You float above a world that is boiling itself into shape. Here's your major science fact. The early Earth's surface was entirely molten, and the process of cooling, solidifying, and forming a crust took millions of years. Only after this crust formed could water begin to pool rain, to fall oceans, to take shape. And here's your odd, wonderful side note. The moon was already there, formed when a Mars-sized object named Theia collided with Earth. The leftover debris formed our beautiful, comforting nightlight. Scientists still debate how much that impact influenced Earth's tilt spin, and yes, its early water systems. Without the moon, tides as we know them may never have existed. You pause. The ground cools under your feet. Not enough to walk on, but enough that volcanic activity starts becoming localized rather than planet-wide. Rain, if you can call it that, falls as sulfuric acid mist, briefly hissing into steam when it hits the ground. Water is trying. The planet is resisting. This battle goes on for millions of years. You'd think the first water would feel triumphant, but it was a slog. Water didn't arrive in a shimmering curtain. It arrived in molecules sneaking into minerals deep inside Earth's mantle, and slowly steaming its way out. And then, as the bombardments slow, the sky begins to form. Not a blue sky. Not yet. More of a soupy,
grey-orange swirl. But clouds begin to gather, and the first raindrops fall.
You stretch out a hand. One hits your palm. It's warm, acidic, but it's water. It begins to fall harder, heavier, for thousands of years, maybe millions. This isn't a drizzle. It's a planetary rinse cycle. Water doesn't just fall, it sculpts. It fills in the cracks of cooling crust. It erodes ash plains into basins. It turns high ground into valleys, and bit by bit it starts to stay. Pools become ponds. Ponds become lakes. Lakes begin to overflow into proto-rivers, and the Earth's surface starts to reflect the sky. That moment when the first real puddle held its first real reflection. You weren't there, but you can imagine it, can't you? The first shimmer, the first ripple, the first water on a dry and restless world. It's funny. We think of water as soft, gentle, peaceful. But in the beginning, water was a revolution. The rain keeps falling. You sit cross-legged on a rocky outcrop, watching droplets splash into steaming craters. There's no sound but the steady hiss of water meeting heat. It's not peaceful. Not yet. It's like the Earth is being slowly persuaded to calm down. But tonight's story doesn't stay here on Earth, because the water falling now, it's not from here. Not originally. To understand where it came from, you have to leave the planet entirely. Don't worry, you won't need a helmet, just your imagination and a soft place to lie down. You drift upwards slowly, leaving Earth's churning atmosphere behind. Space welcomes you, quiet, cold, and glittering with stars that have been dead longer than you can count. You move past the moon, out beyond Mars, to a region of the solar system where sunlight gets lazy and the temperatures drop to please don't touch anything levels. Out here, it's different. Ice is normal. Rocks are not just rocks, they're time capsules. And among these time capsules are the asteroids and comets, strange little bodies packed with the water Earth didn't start with. Your major science and your major science fact. A significant portion of Earth's water may have arrived via icy asteroids and comets during a period called the Late Heavy Bombardment, about 4 billion years ago. These space rocks slammed into our planet and possibly delivered much of the water we drink today. Imagine that your kitchen tap, powered by billions of years of cosmic mail delivery. You float alongside a carbonaceous chondrite, a dark, lumpy asteroid that looks like it's been rolled in soot. Not glamorous, but it's carrying water locked in minerals. Microscopic, yes, but if enough of them hit a young Earth oceans. Now comets. Those dramatic show-offs. You follow one as it streaks past the sun, its icy core fizzing into a long glowing tail. It looks majestic. It's also, scientifically speaking, kind of dirty. Comets are like frozen slushies of water dust, carbon compounds and ammonia. A snowball, sure. A toxic snowball. And here's where the debates start, because scientists still argue about which delivered more water, asteroids or comets. Some say asteroids match Earth's water chemistry more closely. Others point to comets with their flashy, icy payloads. Either way, Earth was in the right place at the right time and got soaked. You imagine the early Earth like a sponge, hot and cracked, trying to absorb every drop flung from space. These impacts weren't gentle. They were violent, explosive earth-shaking. But they added up, drop by drop, bang by bang. You drift past a little icy rock no bigger than a van.
Its tail glows faintly in the starlight. And somewhere inside it, water molecules forged in the heart of a star, maybe even older than the solar system itself. Here's your lovely little odd fact. Some of the hydrogen in Earth's water may be older than the sun. Seriously, formed in interstellar space before our solar system even coalesced. The next time you drink water, you might be sipping something that predates the planet you're standing on, which is humbling. Back on Earth, the rain continues, but this time it's blending with what's already here. Water from space is joining water from Earth's mantle, and for the first time, there's enough for it to pool. You return to the planet, slowly clouds swirling beneath you. You land near a vast depression that's filling with warm, mineral-rich water. No fish, no sand, just a shimmering expanse under a peach-colored sky. This will one day be the ocean. You crouch and run your fingers through it. It's not clean, not yet. It tastes like salt metal and whatever gases the volcanoes are burping out today, but it is unmistakably, wonderfully water. And you here in this moment are seeing it become itself. It's wild, isn't it, that something as soft and ordinary as water has an origin story that involves space explosions, asteroid trauma, and deep planetary burps.
Yet here it is already shaping the land, already deciding where life might dare to begin. You lie back on a warm rock, stare at a sky full of stars, and let this thought ripple through you. The next time someone says, "Water is just water," you'll remember this: that your bath, your tears, your tea, your blood, they were forged in stardust, carried by comets, delivered by fire. Water doesn't just come from somewhere, it comes from everywhere. You wake up soaked in sunlight and steam. The air smells like metal and warm stone. The ground beneath you is still cooling from its tantrum years, but now finally it's wet. Not puddly, not swampy, but wet in a way that feels permanent. You sit up on a rocky slope and look out across something you've never seen before in all your dreaming through time. A horizon that shimmers. It's not quite an ocean yet. It's more like Earth trying out the idea of one. There's no surf, no gentle waves, just broad bubbling sheets of water stretching across craters and lava plains. Every now and then steam hisses from a crack in the earth, like a tea kettle left unattended. You're watching the planet cool into something drinkable. Let's walk to the edge. You squish through warm mud. It's black and grainy volcanic soil mixed with minerals that are already starting to dissolve into the water. There are no pebbles yet, no shells, no fish to dart away from your footsteps. But there's a silence here that feels sacred, like the planet is holding its breath. And then, splash. The first raindrops hit the water. It sounds like nothing, like background noise. But this moment, it's monumental. Here's your major science fact. Once the Earth cooled enough, volcanic steam and atmospheric moisture began to condense and fall, creating the first continuous rainfall. These rains, likely acidic at first, lasted for thousands or even millions of years, eventually filling basins and forming permanent bodies of water. Now imagine the first rainstorm that didn't boil off immediately. The first time water stayed put. The planet would have looked like a hot spa gone rogue. Water sizzling over rock, swirling with metals and chemicals. A place where nothing lived yet, but everything was preparing for it. Here's your odd little aside.
Some early rains may have carried tiny bits of glass. Volcanic eruptions launched droplets of molten rock into the sky, which cooled into glass beads before falling. Yes, Earth's earliest showers may have included literal glass rain. Not ideal for a picnic. You take shelter under a ledge as another steam burst erupts nearby. The ground shakes a little, not violently, just enough to remind you that the mantle still has opinions. But things are calming now. You walk beside a wide, shallow basin that's slowly becoming a proto-ocean. The water is full of dissolved minerals, iron, magnesium, even traces of gold. Not much oxygen yet. No ripples, no algae mats, no floating leaves. Just water that's figuring out how to settle. Scientists still debate how long it took Earth to form full oceans. Some models say it happened astonishingly fast within 100 million years of formation. Others suggest it took longer, that Earth went through dry spells and wet recoveries before the seas stabilized. What we do know is this: once the oceans appeared, they stayed. That's the weird part. You'd think something as delicate as water would come and go. But Earth has kept its oceans for over 4 billion years. They've shifted, sure. Frozen, boiled, risen and fallen. But they never fully left. You step into the shallow edge. The water is warm, dense, a little syrupy with minerals. It doesn't sting exactly, but it makes your skin tingle. You whisper, "Hello," even though nothing's there to hear it. Not yet. You gaze up at the sky. It's different now, thick with clouds, but no longer angry. Sunlight filters through in hazy orange bands. The clouds hang low and heavy, like they're still deciding whether to keep raining or take a nap. Then it begins again. A slow, soft rain. This time, the drops are bigger, colder, more familiar. You hold out your hand. This is not sulfuric drizzle anymore. This is rain. You let it fall on your face. It doesn't taste good, not yet, but it doesn't taste like poison either. Earth is softening, learning to hold water, not just burn it off. And you're sitting at the beginning of every ocean sunset that ever was. Every bathtub reflection, every puddle jump, every single sip of life. Here's a final thought for this drift. The first puddles on Earth weren't special to anyone but time. No one gasped. No one took a photo. But they were the beginning of everything. Steam still curls from the ground, but now it rises more slowly, like the Earth itself is starting to breathe differently. You walk along a shoreline that didn't exist a few million years ago. It has no name, yet, no maps, no borders. Just warm water, lapping over volcanic sand. And for the first time, it stays. The puddles have become pools, the pools, lakes, and the lakes are slowly linking up, folding into something massive. An ocean is being born. You sit on a flat rock and dangle your feet into the water. It feels alive, even though nothing actually lives here yet. There's no kelp, no whales, not even bacteria. But it still hums, like it's rehearsing. You squint across the horizon. Steam still rises from distant cracks in the Earth's crust, and waves form for the first time. Not from wind, not yet, but from the heat churning beneath the ocean floor. Hydrothermal vents bubble like angry teapots, releasing superheated water laced with metals and gas. They hiss into the silence, shaping the chemistry of this new ocean, one plume at a time. Here's your major science fact. Earth's oceans likely formed from a combination of outgassed water vapor,
space-delivered ice, and slow seepage from the mantle, eventually creating bodies of water that covered up to 70% of the planet's surface. They became the dominant feature of Earth's appearance and climate. You stand and walk along the edge of one of the larger basins. It smells metallic, like iron and sulfur. Every few meters, bubbles rise to the surface, carbon dioxide and methane most likely. You're not breathing the air deeply. Not yet. It's not ready. And here's your weird little side note. Some scientists believe that early oceans may have had a reddish or greenish tint thanks to the dissolved iron and lack of oxygen. That iconic deep blue we picture now. That came later, after life messed with the chemistry. You squat down and run your hands through the mud. It's not just dirt, it's minerals in motion clay, rich with future possibilities. You don't know it yet, but this slurry will be the first nursery. The first place where atoms start holding hands. The first place chemistry dreams of biology. But we're not there yet. Right now, the ocean is still hostile. Not to you, you're just visiting, but to life as we know it. It's hot, acidic, bursting with metal ions. It's water, yes, but it bites. The earth is still cooking. You take a breath of the air and taste the difference. It's thick with volcanic gas, carbon dioxide, hydrogen sulfide, ammonia. No ozone, no oxygen. If you lit a match, it would be the rudest mistake you'd ever make. And yet, this is progress. The crust is no longer lava. The sky is no longer raining fire. And the water no longer evaporates instantly. You close your eyes and imagine time passing. Millions of years. Millions more. The water doesn't just stay, it spreads. Earth becomes a water world. From orbit, it now glows blue, even though no eyes have evolved to see it yet. Blue. Because of light scattering, because of depth, because water bends sunlight in just the right way. That color you know so well from globes, weather maps, and travel ads. It was born here in silence, under a sky that still doesn't know how to be blue. And scientists still debate when Earth's water stabilized into a full hydrosphere. Some say it happened early, fast, and violent. Others argue it was a gradual process, a slow seep and steady rain. The truth may be somewhere in between. But the outcome is clear. The planet now has oceans, which means it also has shorelines. You sit on one now, watching steam rise and water reflect the heavy sky. There's a rhythm forming, a pattern. Not yet waves, but swells. Not yet tides, but pulses. And for the first time in Earth's history, there's a place you could almost call peaceful. You stretch out on the warm rock and exhale. It's still too early for life. Too early for fish or plankton or even a single cell. But the water is ready. It waits. Patient, gentle, powerful. All the rivers, all the rain, all the tears, all the thirst, every droplet you've ever touched traces back here. Before it ever ran in streams or fell in storms, it gathered here quietly with no one to witness it but time. And now you. The world has gone quiet in a new way, not because it's empty, but because it's settling. You walk along the edge of one of Earth's earliest oceans. It's still hot, sure, but the water no longer boils where it touches the land. The steam has slowed to a whisper. The rain now falls in gentle sheets instead of tantrums. It's not calm, but it's calmer, like Earth finally decided
to let something live here. And that something is starting. You crouch by a tide pool the size of a bathtub. It's still faintly bubbling, its edges crusted with minerals, iron, zinc, phosphorus, all swirling lazily in the soup. You dip your fingers in and the water feels slightly oily, faintly metallic. You're looking into a chemical experiment 1 billion years in the making. You're watching life almost begin, but not quite yet. Here's your major science fact. Scientists believe that life likely began in water, specifically in warm, mineral-rich pools or hydrothermal vents. Water wasn't just the background, it was the medium and the catalyst helping molecules bounce, break, combine, and try again until something clicked. And no one really agrees on where that click first happened. Some argue for deep-sea vents, where water and heat meet rock in a bubbling chemical stew. Others favour shallow pools exposed to cycles of evaporation and concentration, places where molecules could get stuck together in the mud like shy strangers at a dance.
Scientists still debate which environment was more likely, and maybe we'll never know. But both have one thing in common: water, water, water. You shrink yourself to molecular size just for a moment. Now you're floating in that warm tide pool. Amino acids spin around you like lost puzzle pieces. They drift, collide, and occasionally stick. Phospholipids line up shyly, forming membrane-like bubbles that quiver and pop. Nothing is alive yet, but everything is trying to be. This isn't a lightning bolt moment. There's no magical spark, no booming voice shouting, "Let there be cells." It's more like millions of chemical accidents happening at once, most of them dead ends. But some aren't. You hover over a tiny lipid bubble that somehow traps a few molecules inside it. It doesn't do much, but it's a beginning. A whisper of compartmentalization, the first hint that a structure might someday mean function. You could call it pre-life, proto-life, a rehearsal, the equivalent of atoms playing with hand puppets before discovering Shakespeare. You drift over to another site, a crack in the sea floor where alkaline hydrothermal vents are spewing hot, mineral-rich water into the ocean. Chimney-like towers rise up covered in bubbles and black sludge. These places are teeming with energy gradients, places where molecules can fall downhill in just the right way to build something new. You watch carbon molecules link. You see RNA fragments twitch. You see chaos swirl into the shape of something more complicated than it was 5 minutes ago. You don't quite know why it's happening. No one does. But it is. And here's your wonderfully weird fact. Some of the earliest Earth-water reactions might have produced formamide, a molecule that smells like almonds and may have played a crucial role in forming RNA and DNA precursors. In other words, your entire genetic code might owe its existence to a faint whiff of almond. Back on the surface, the tide pools bubble quietly. You press your ear to the edge of one and imagine you can hear the tiniest sizzle of prebiotic chemistry happening beneath. It's not exciting yet. It's not even visible to the naked eye. But give it 1 billion years and this will be everything. The first oceans are now stable. They stretch across the globe, sloshing under sulfur skies. Their waves are small but consistent. Their tides, thanks to the moon, are beginning to shape shorelines. Water is sculpting the world before anything even crawls across it. You walk along a jagged ridge and watch the way the waves hit the stone.
the first erosion, the beginning of beaches. Not soft sand yet, but proto-sand, sharp mineral fragments worn smooth one lap at a time. And in the tide pool beside you, a little bubble shivers, divides and becomes two. It's not technically alive, but it's one terrible decision away from becoming your great-great-great-grand chemical ancestor.
You lean down and whisper,
Don't mess it up. You don't expect a response. But the water ripples anyway. There's something stirring in the chemistry. A pattern trying to hold itself together. And you know if it works, if the molecules hold just long enough to copy themselves, then Earth's quiet pools won't be quiet much longer. You lie back again, warm stone under your spine, and listen to the sea breathe. The ocean doesn't roar yet. It hums. And somewhere inside it, life is rehearsing its first line.
You wake to the sound of bubbles,
Not from soda or bath water, but from chemistry, still trying to become biology. The tide pools are still here, but they've changed. They're thicker like soup that's been simmering too long. The surface glistens with strange oils. The air smells like salt copper, and something faintly rotten, like Earth's kitchen, is experimenting and not reading the recipe. You crouch next to a shallow pool and peer inside. Something just wiggled. It wasn't graceful. It wasn't smart. But it moved not because the wind pushed it, not because of heat, but because it wanted to. Or rather, because its structure accidentally resulted in motion, and motion happened to be helpful. That's all evolution needs. Really an accident that works. You lean closer. Inside the soup, something membrane-bound is jiggling. It's not a cell yet, but it's close. Inside its oily shell, molecules are beginning to self-replicate, copying imperfectly, making mistakes,
getting slightly better and sometimes worse. You're watching the very first drafts of life. Here's your major science fact. Life likely began when simple molecules formed self-replicating systems, possibly RNA-based, that could mutate, persist, and evolve. Water wasn't just where this happened. Water made it possible by allowing molecules to mix, meet, and bump into each other over and over again. And scientists still debate what came first, RNA proteins metabolism, or even lipid structures. Some even wonder if life started multiple times and only one version survived. There's no lab for this part of the story. Only fossils too small to fossilize and guesses that sparkle with possibility. You lie down beside the pool and close one eye. Now you're seeing shadows of cells, protocells, clustered like little jelly beans in the shallows. Some dissolve, others hold. One divides in half, not with purpose, but because that's what water does, it helps things split, spread, recombine. Where there's water, there's motion. Where there's motion, there's chance. And where there's enough chance, life sneaks in. The water glows faintly green now, not from algae, not yet, but from minerals reacting under sunlight. And oh yes, the sun finally warming the planet with enough consistency that cycles begin. Day and night, heat and cool, evaporation and condensation. You follow one molecule just for fun as it floats up in vapor, condenses into a cloud, rains down, gets sucked into a tide pool, joins a membrane, and is part of something alive. You might have just watched a hydrogen atom become part of a future tree. Back near the shore, the oceans are deeper now. The atmosphere is thicker. The air is still too dangerous for you to breathe deeply, but it's getting better. Slowly.
Almost sneakily, water is reshaping everything. You look down at the sand. The waves have smoothed it out into something gentle. The first signs of erosion that leads to sediment, that leads to layers. Those layers will one day tell stories to paleontologists' stories. The water is writing right now without ink, without a plan. Here's your odd fact tonight. Some of the first living things may have used iron and sulfur instead of sunlight or oxygen. These organisms were chemosynthetic. They ate rock juice. They would have lived near deep-sea vents, thriving in environments so extreme they make microwaves look relaxing. You look back at the tide pools. The chemistry show is still going, but some of the performers are getting organized. Lipid membranes are sturdier. Molecules are aligning into more consistent chains. There's still no DNA, no mitochondria, but if you squint, you can see it coming. You drift down to the waterline again. Sit still. Let the rising tide lap at your ankles. In the distance, lightning flashes over the water. The air sizzles with energy, the kind that might break a molecule or build a new one. Everything feels close. Close to working. Close to living. Close to the day some molecule whispers, "Copy me," and the whole planet changes forever. And what's holding all of this together? Not a lab, not a god, not a spreadsheet, just water. Water with just the right balance of chaos and structure. The great mixing bowl, the original medium, not just where life begins, but how. You sigh, you stretch, you yawn. And as the stars emerge, faint behind thick clouds, you close your eyes to the lullaby of tide and chemistry, knowing tomorrow some of those bubbles will divide again. And the ones that do it best will keep doing it. Forever. You wake to a rhythm you didn't hear before. Not a heartbeat, not quite music, but something moving in cycles. A pulse in the waves. A hush in the wind. The planet is settling into patterns, and the water is beginning to teach the land how to breathe. You walk down a slope of soft red rock. The oceans stretch out before you, calmer now, deeper. The atmosphere has thickened with nitrogen carbon dioxide and a touch of methane, giving the sky a syrupy orange haze. But down at sea level, something incredible is starting to happen. The water, once just a chemical playground, has become a cradle. And inside that cradle, life is no longer theoretical. You kneel at the edge of a sun-warmed tidal pool, squinting down. This isn't soup anymore. It's swarming. Microscopic creatures, tiny blobs of lipids, RNA, and proteins are multiplying. You can't see them, but they're there. These are prokaryotes, the first true living cells, simple, but astonishingly good at one thing: staying alive. They have no nucleus, no legs, no eyes. Just a jelly bean shape and a sense of purpose that you can feel in your bones. They're the original minimalists. Here's your major science fact. Around 8 billion years ago, Earth's first cellular life formed single-celled prokaryotes, began to emerge in water. These early organisms may have lived in shallow pools or near deep-sea hydrothermal vents, using chemical energy rather than sunlight to survive. You follow the water as it flows from shallow pools down to the sea, carrying with it tiny passenger cells that divide, mutate, survive and repeat. They're not just floating, they're exploring, drifting into new chemical environments. Some like it hot, some don't. Some stick to rocks, some prefer drifting. All of them, they owe everything to water. Scientists still debate exactly how those early cells formed. Did lipids organize themselves into membranes first? Did RNA appear independently, and get lucky enough to be trapped inside a bubble? Or did everything evolve together like the world's slowest dance troupe? No one knows. But the performance, it was spectacular, and it's far from over. You step into the shallow water and watch something dark and squishy ripple across the sea floor. Algae. Not quite. These are stromatolites, layered structures formed by colonies of ancient bacteria, some of the earliest fossils we've ever found. They look like blobs of wet carpet, but they're busy. These microbial mats are photosynthesizing, using sunlight to convert carbon dioxide into energy and releasing a little bonus gas, along the way, oxygen. And here's your odd little fact for tonight. Oxygen was once a toxic waste product. For early life, it was annoying, even deadly. Most of the planet was anoxic, no free oxygen. When cyanobacteria started releasing oxygen into the oceans, it caused what scientists call the Great Oxidation Event, which sounds like a very intense band name, but was actually a planetary shift that killed many early microbes. Water didn't just host life, it helped reshape the atmosphere. You follow a patch of ocean glowing faintly green. Oxygen bubbles rise like tiny pearls vanishing at the surface. The air isn't breathable yet, but it's changing. The ocean's once chemical chaos are now living systems. The water is full of tiny cells, replicating, exchanging genes, experimenting with metabolism. Some eat light, some eat sulfur. Some just float and copy themselves like lazy geniuses. And the more they thrive, the more oxygen they release. The atmosphere slowly begins to shift. More blue in the sky, more calm in the waves, more structure in the chaos. You sit on a warm rock and let your fingers trail in the tide. The water is different now, biological. It carries more than minerals, it carries memory, DNA drifting like microscopic messages in bottles. You think of how far we've come, from comets crashing into lava to quiet bubbles copying themselves under a rising sun. From no oceans to oceans full of microbial ambition. And the most astonishing part, they're still here. Those prokaryotes, they never left. They're in your gut, in your water, in hot springs and under the Antarctic ice. Billions of years old and still quietly running the place. You lie back and stare at the sky, now streaked with clouds that weren't there a billion years ago. That weren't even possible until life changed the air. You smile, because water didn't just give us life, it gave life the chance to keep going. The sky is bluer now. You notice it first when you open your eyes, soft light filtering through clouds that finally look like clouds, not toxic mist. You sit up slowly, brushing damp sediment from your arms, and look out over an ocean that feels strangely familiar, calmer, deeper, older in that quiet, wise way water gets after holding secrets for a few billion years. And this morning, something is missing. The world is no longer empty. It swims. You lean over a tide pool just as a flicker of motion zips through the water. Not a microbe, not a chemical ripple. Something wiggles with intent. A tiny squirmy blur, maybe no longer than an eyelash, but undeniably alive and aware of movement. You just met your first eukaryote. Here's your major science fact. About 2 billion years ago, cells evolved that were no longer simple sacks of molecules. They developed internal compartments, including a nucleus, to store DNA. These were the first eukaryotic cells, the ancestors of everything from algae to humans. You press your face closer to the water. It's shimmering with single-celled eukaryotes, some shaped like raindrops, others like snowflakes that forgot how to freeze. They're faster than prokaryotes, smarter in a way. They're doing cellular algebra processing energy, coordinating internal traffic, managing a nucleus like tiny bureaucrats. And the secret to their power, endosymbiosis, a beautiful mouthful of a word that means let's team up. One ancient cell engulfed another, but instead of digesting it, they formed a partnership. The engulfed cell became the mitochondrion, the powerhouse of the cell. Yes, that line you memorized in school. Later in some lineages, another engulfed cell became a chloroplast, turning sunlight into energy. Scientists still debate how many times this happened. Was it once? Twice? 1,000 failed starts before one lucky cell said, "Hey, wanna stay forever?" You watch them dance under a sliver of afternoon light, dividing, rejoining, sharing DNA like gossip. And the water, it's the network, the stage, the medium that lets life recombine endlessly. It lets cells bump into each other, wrap around, test the chemistry, make mistakes, and sometimes invent symbiosis. Here's your oddly heartwarming fact. Some eukaryotic cells today still eat bacteria for fun. They catch them, pull them in, and dissolve them. But every once in a while, rarely they don't. They hold on to the guest, keep feeding it. And just like that, a new kind of life begins. You stand up and stretch, gazing across the water. The ocean surface is alive now, not just with cells, but with algae, mats, ribbons of green, squirming across the shallows. These aren't plants, not yet, but they're photosynthesizing, pumping oxygen into the air with every tiny flick of their chloroplasts. The oxygen levels are rising, slowly, but they're rising. The more oxygen, the more energy cells can store. The more energy, the more complexity. And with complexity comes drama. You walk along the shore and notice something new: predation. Some of these eukaryotes hunt. They chase. They bump. They engulf. It's a microscopic feeding frenzy, barely visible, even with a good imagination, but it's happening. And it's new. Life is no longer just surviving. It's competing and evolving faster than ever. Water doesn't just carry this explosion. It encourages it.
Where else can cells move in 3 dimensions? Where else can nutrients float to you without your help? Where else is every surface liquid, every direction possible, and every mistake a potential mutation? You sit on a boulder near a slow-moving inlet, your toes dangling in the warm tide. The sea foam hisses against the rocks, and for the first time in a long time, you feel like Earth is breathing regularly. Here's something weird to drift off on. The water inside those early eukaryotic cells, still with us. The cytoplasm that jelly inside every one of your cells is evolution's memory of those original oceans. You carry a drop of that ancient sea inside you, every minute, every breath. You lie back, salt crusting your skin, and look at the sky. Above you, birds have not yet flown. Fish have not yet darted. Amphibians have not yet flopped onto land. But the ocean, it's already plotting. The water beneath you is genius in motion, coaxing molecules into life, coaching cells into complexity, and humming softly as it turns tiny, slippery nothings into the first hints of bodies.
Sleep now. Let your breath match the waves. And remember everything you are, every nerve, every organ, every flicker of thought began here, in this water, on this planet, with these cells. You stir before dawn, the sky still deep grey above a restless sea. The tide rolls in slow pulses, steady and strong. You're lying on a coast that didn't exist 1 billion years ago, but the water has been here all along, waiting patiently for something brave to crawl out of it. And now, something is. You rise and walk to the edge of a tide pool as the light shifts. The water is calm, but beneath the surface, it's humming with movement and ambition. Life is still microscopic, but it's gaining form organisms with tiny tails, fins, spines, and mouths. Not just blobs anymore. Bodies.
Some of these are multicellular, and that changes everything. Here's your major science fact. About 1.5 billion years ago, life transitioned from single-celled organisms to multicellular organisms, allowing for specialization cells devoted to movement, digestion, reproduction. This was the beginning of body plans, the blueprints for plants, animals, fungi, and everything that has organs, limbs, or a nervous system. You sit on a damp boulder and squint at a shallow pool, just catching the rising sun. Floating inside are the ancestors of jellyfish and sponges, soft-bodied creatures, pulsing gently through the water. They're the first animals, drifting like phantoms, with nowhere to be absorbing nutrients from the water and sometimes each other. This is evolution's long, quiet inhale. The Ediacaran period, a time of strange soft beings with no eyes and no mouths, just surfaces and ripples and mystery. But life doesn't stay passive for long. As oxygen builds and ecosystems become more layered, the water begins to fill with competition. Predators, prey, niche warfare, and the water. It's the perfect battleground. Every chemical advantage, every speed boost, every sneaky adaptation can mean the difference between floating and feeding, or being lunch. You watch a flatworm ripple its way toward a colony of algae, absorbing nutrients as it passes. Nearby, a slightly larger creature moves toward it, intentionally. Something with a front end, a plan, a motive. You murmur, and so it begins. By the time you reach the Cambrian seas, it's chaos in the most magnificent way. Trilobites scurry along the sea floor. Jellyfish float above. Anomalocaris, a swimming nightmare with barbed arms and donut-shaped jaws, patrols the mid-water like the first boss battle in Earth's biology game. This moment is called the Cambrian explosion, a relatively short span around 540 million years ago, when most major animal groups appeared in a burst of evolution and experimentation. Scientists still debate what triggered it. Was it rising oxygen? Changing ocean chemistry, evolutionary arms races. The invention of eyes may be all of it, maybe something else entirely, but the outcome is undeniable. Life diversified like never before, and it happened in water. Water gave organisms space to grow large without collapsing under their own weight. It gave nutrients dissolved gases and mobility. The ocean became an evolutionary pressure cooker, a floating laboratory of body parts, instincts, and wild anatomical ideas. You glide alongside a hallucigenia, a tiny creature that looks like a walking toothpick with spikes and noodle legs. No one's still quite sure which end was the head,
It's equal parts adorable and terrifying. You love it immediately.
And here's your odd fact.
Some early marine creatures may have had armor made of minerals pulled from seawater. Not for battle necessarily, possibly for support, or as a failed fashion experiment. Nature tried everything once. Some of it stuck. You pause above a reef made entirely of sponges and microbial mats. No coral yet, but it's bursting with energy, every crevice filled with filter feeders, burrowers, grazers. Tiny ecosystems layered in time. And among them, something flicks sideways and vanishes. A notochord, a primitive backbone, a flicker of you. The first chordates appear distant ancestors of fish mammals, dinosaurs, birds, and humans. They don't know where they're headed, but they've got just enough structure to try something new, like swimming faster or aiming for land. Because eventually, someone gets curious. Some little fishy creature gets stranded in a tide pool, flops a bit longer than expected, and doesn't die. And suddenly, the impossible becomes evolutionarily convenient. You smile, because it's always been water from the first molecule to the first backbone, from floating blobs to finned predators. Water doesn't just host life, it challenges it. And life, again and again, rises to meet it. You lie back in the sand. The waves tickle your toes. Above you the stars pale into a pale blue sky that might one day shelter forests, lungs, and fire. But tonight, it still belongs to the sea. You stir to the sound of distant thunder, but it's not thunder. It's waves crashing high and wild, roaring onto a shoreline that just yesterday didn't exist. You sit up on a sloping beach, half buried in sea foam, watching a new kind of drama unfold. The sea hasn't just birthed creatures now, it's shaping continents, writing weather, carving history with every droplet. The earth once fire and silence is now water in motion. You walk to the edge of a cliff and look down. A river snakes across the land like a vein, fresh and insistent, winding from highlands to ocean, dragging silt and memory behind it. This is where water learns gravity. Here's your major science fact. Water evaporates, rises, condenses, and falls, forming the hydrologic cycle, or water cycle. It connects oceans, air rivers, and ice. Driven by solar heat and gravity, this continuous loop has shaped the planet's surface for over 3 billion years. You close your eyes, inhale. You can feel it, the flow in the air, the tension in clouds just before they break. The scent of petrichor on dry stone as the rain gets close. And then drip, 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 downpour. You lift your face to the sky as cool rain kisses your skin. This isn't the acidic mist of Earth's early years. This is real rain falling through a sky rich with nitrogen and oxygen, soaking into soil, bouncing off leaves, running down gullies. Rain with somewhere to go. You follow it. The raindrops collect in rivulets, join into streams, and spill into a river. The river runs over rock, grinding it down, grain by grain. Every bend, every ripple, every sudden drop is sculpting earth. You crouch beside a waterfall as it drills into the rock below, creating a plunge pool. It doesn't roar, it works quietly. And over time, it wins. Scientists still debate when major river systems formed. Some say Earth's continents were already shaped by the late Precambrian. Others argue the biggest recognizable rivers, like the Amazon Nile or Mississippi, are relatively young, mere teenagers in geologic time. But even before names or maps, water was carving paths. You leap forward in time. Now you're gliding over glaciers, vast moving rivers of ice. Their slow grind against bedrock has carved valleys, sculpted fjords, and left behind lakes so cold and blue they hurt to look at. Water doesn't always flow. Sometimes it crushes silently, rearranging everything beneath it.
And here's your delightfully strange fact. Some of Earth's oldest ice cores taken from Antarctica contain bubbles of air that are hundreds of thousands of years old. In a very real sense, water is storing memories, tiny archives of Earth's past atmosphere, temperature, and even volcanic eruptions. You skate literally across the surface of a frozen lake, watching cracks spider beneath your feet. Each crack is a whisper, a sigh, a promise to melt again someday. The seasons, too, are now cyclical, guided by Earth's tilt and orbit. Snowmelt feeds rivers. Rivers flood valleys. Water soaks into the ground, finds aquifers, disappears for centuries, only to rise again in a mountain spring. You take a drink from one. It's cold, perfect, probably ancient. And here comes another transformation lakes. You wander beside one flat as a mirror reflecting clouds that weren't there an eon ago. Around its shores, grass begins to grow. Insects buzz. Amphibians chirp. Life has followed the water inland, adapting not just to salt and tide, but to freshwater depth and distance. You see a frog leap, a fish snap at a fly, a dragonfly skim the surface wings catching sunlight. Everything here, everything green, everything moving, owes its existence to water's long, careful editing of the land. You sit on a rock at dusk and dangle your hand in the current. The river you're next to might become a canyon, or a waterfall, or a floodplain, or a trickle dry in summer, roaring in spring. Water doesn't pick favorites, it just moves. Scientists still debate how quickly water can transform landscapes. Some say it takes millions of years to carve a canyon. Others have seen rivers reroute in a single storm, entire coastlines collapse in an afternoon. Water has patience, yes, but it also has moods. Tonight it's gentle. You lie back and listen. To the gurgle of runoff through moss. To the tickle of wind-driven ripples against reeds. To the rhythm of rain on distant cliffs. You feel small, but not irrelevant, because you are made of water. And water remembers how to return home. You're dreaming before you even realize it. Not the usual dreams, no. Flying, no teeth. Falling out, just visions of rivers, winding clouds, swirling ice cracking, and all of it happening in quiet harmony. As if the planet is breathing deeply, finally at ease with its rhythms. But when you open your eyes, things feel different. There's life all around you now, not just in the water, but beside it, on it, above it. The ocean hasn't changed, but the coastline has company. You sit on the bank of a wide estuary, watching tall green things sway in the breeze. Plants, real ones, rooted vascular, some with leaves that dance toward the sun. The air smells of soil and salt. And somewhere in the mud, something croaks. Welcome to the Devonian period, sometimes called the Age of Fishes, but honestly, that's underselling it.
Because while fish are everywhere now, and oh, they are, the real headline is this life is moving onto land.
Here's your major science fact.
Roughly 400 million years ago, plants and animals began to colonize land in earnest. First came mosses and liverworts, then vascular plants, then the first forests. And soon after, arthropods, amphibians, and creatures with lungs. And every one of them carried water inside. You stroll up a wooded slope, yes, a wooded slope, and marvel at the lush chaos of it all. Ferns taller than you, early trees like Archaeopteris, with no flowers but ambition enough to build the planet's first vertical skyline. The air is thicker, fresher, spiced with volatile oils from plants you can't name. Dragonflies with 2-foot wingspans buzz past. Millipedes the size of dachshunds rumble through the undergrowth like shy buses. And the rivers, they're no longer just transport routes or sculptors of stone. They're veins feeding forests, guiding roots, quenching thirst. Water has become the infrastructure of ecosystems.
You pause beside a small pond where frogs, yes, actual frogs, leap from rock to leaf. Behind you, a ripple in the brush. You turn. Something with scales and little stumpy legs eyes you suspiciously before slinking back into the weeds. An early tetrapod, a creature that once had fins, now making do with proto-limbs. The first ancestor of every animal that ever walked on land. And here's your strange but true fact. Many early amphibians likely returned to water to reproduce. Their eggs needed moisture. Their skin could dry out. Even as they crawled inland, water still called the shots. You walk further past a stream that burbles with confidence. It carves through sandstone, pulls nutrients from rotting leaves, loops around a grove of club mosses and spills into a still pool where new life wriggles in the mud. It feels stable now, predictable, but it's not. Because just as water nurtures life, it also ends chapters. Over the horizon, something stirs. Not a predator. Not a volcano, but a changing climate. Rainfall shifts, seas rise, temperatures waver, oxygen levels plummet. And slowly, so slowly you might not notice until it's too late, species begin to vanish. A mass extinction is coming. 1 of 5. Scientists still debate what triggered the late Devonian extinction, possibly a combination of ocean anoxia, rapid plant evolution, and global cooling. But water played a role. When oceans lose oxygen, when rivers flood too long, when rainfall stops coming, ecosystems collapse. You sit on a boulder and watch the sky darken. Not from ash, not from fire, just absence. Fewer birds, fewer insects. A strange stillness spreading through the forest. You whisper, "I thought we had more time." Water giveth, water resets. But it's never the end. You press your palm to the surface of a quiet pond. The water is warm, still. But it's not done. You can feel it. It's watching, waiting, ready to flow again, because water never stops. It moves through clouds into trees across gills under skin. It pauses, but only briefly. Then it goes again, recycles, renews, remembers. You lie back in the grass surrounded by ferns and dragonfly wings and echoes of what was. Some species will go, others will adapt, and the water, it will keep moving. Right through the heart
of the next age. You wake up somewhere dry. That's your first thought. This place feels thirsty. The air is thinner, the breeze dustier. You sit up slowly, surrounded by sweeping plains, rocky cliffs, and patches of fern-like plants that rustle like brittle paper. There's still water here. It murmurs in rivers below, hidden behind ridgelines pooled in low valleys. But it's withdrawn, more selective now. No longer a blanket, now a thread. And across that thread, dinosaurs. You spot one almost immediately, massive and slow-moving neck, swaying in rhythm with the tall trees it grazes on. A sauropod, possibly an apatosaurus, lumbering beside a broad, lazy river. Its skin is dusty, pebbled like an elephant made of stone and memory. You freeze, but not from fear, from awe, because the planet has figured it out. Land and water are in balance. Here's your major science fact. During the Mesozoic era, from roughly 250 to 66 million years ago, Earth's climate was warmer and more humid, with high sea levels and widespread shallow inland seas. These moist, tropical environments helped support vast forests, lush wetlands, and the incredible diversity of dinosaurs. You follow the riverbank, where turtles bask on logs and enormous crocodilian eyes just barely break the surface. The water is teeming coelacanths and lungfish drifting in deeper pools, amphibians lurking in the shadows. On the shore, feathered theropods peck the mud for insects. This world is full bursting with form and noise and movement. You hear a distant splash, maybe a predator chasing prey, maybe just a clumsy herbivore cooling off. You can't tell, but it reminds you this world belongs to water. It's there in the swamps and lakes, in the thick clouds above and the moist soil beneath, in the bloodstream of every beast that thunders past you. You stop at a wide delta where a river kisses the sea in slow braided fingers. Mangrove-like trees grow tall here, and pterosaurs perch among them, preening lazily in the sun. And here's your odd but beautiful fact. Some marine reptiles like plesiosaurs may have given live birth in the water, just like whales today. They never laid eggs. The ocean was their womb, their nursery, their grave. You dive into the coastal shallows and swim alongside a mosasaur, its jaw lined with teeth like railroad spikes. It passes you without pause, utterly indifferent to your existence. You are nothing here. Just another passenger in water's long, unstoppable story. You breach and look inland. Far away, a volcano puffs smoke, and with it comes unease. You've seen this before. Earth has grown rich again, lush, alive. But history whispers warnings, and the breeze carries ash. You climb a low ridge, dry moss, crunching underfoot. From the summit, you see it a horizon, too red a sky, too still. Somewhere across the planet, something shifts. Some scientists believe the end began slowly with massive volcanic eruptions in the Deccan Traps of present-day India. Others think it ended suddenly with a comet or asteroid strike that threw up enough dust to darken the sky for years. Scientists still debate the exact sequence of events, but they agree on the outcome. Water changed. Rainfall patterns collapsed. Rivers dried. Temperatures swung wildly. The hydrological cycle, once stable and generous, faltered. Plants withered. Herbivores starved. Predators failed. And one day, you stand near a still lake and nothing moves. The frogs are silent.
The sky is grey.
The great creatures are gone. The Cretaceous Paleogene extinction event, roughly 66 million years ago, wiped out 75% of Earth's species, including the non-avian dinosaurs. Life didn't vanish, but it reeled, stumbling into a new era. You kneel at the water's edge. It reflects only clouds, and your face. Still here, still watching. But don't mourn just yet. Water, as always, is already preparing the stage for what comes next. You follow a narrow creek inland, where small mammals with twitchy noses scurry beneath shrubs. Their bodies are humble, but their brains are buzzing. The mammals that survived were small, adaptable, water efficient. They could burrow, hibernate, migrate. They could wait out the chaos, and water helped them do it. You lie down in the tall grass and stare up at a sky that's learning how to shine again. It will take millions of years for forests to regrow, millions more before humans show up. But the blueprint, it's already written.
In every trickle, every cloud, every cell. You close your eyes and listen to the water again as it carries history forward in ripples. It has mourned. It has rebuilt. And it's not done. It's morning, and the planet is quiet, but not still. The water is flowing again. You're walking beside a gentle stream that glides over rounded pebbles. The trees are smaller now, familiar. Oaks, beeches, evergreens. Birds chatter overhead. Insects drone lazily in shafts of golden sunlight. A deer lifts its head from the bank, twitches an ear and vanishes back into the brush. The age of dinosaurs is gone, but the age of water never ended. You bend down and touch the surface of the stream. It's cool, clean. You cup your hands and take a sip. It tastes like every river you've ever tasted, and none of them at all, because this water has travelled through clouds and soil, mountains and aquifers, plants and lungs. And now it's here. Here's your major science fact. After the dinosaurs vanished, the Cenozoic era began roughly 66 million years ago and still ongoing. It's known as the Age of Mammals, but it's also when modern water systems, glaciers, lakes, wetlands, and the full structure of rivers, as we know them, began to resemble today's Earth. You hear it in the rain, tapping the leaves. You feel it in the wind that smells faintly of moss and cold stone. Everything seems closer now, more recognizable. The continents have mostly settled into place. The atmosphere is breathable. The oceans know their boundaries. But the water is still busy. Glaciers creep across continents, carving valleys and pushing rock like slow-motion tsunamis. Rivers widen and deepen, shaping floodplains and deltas. Lakes form, dry out, reform again. Every drop still sculpting Earth like it's a hobby project that never ends. You stand on a tundra slope as ice melts around your boots. The last ice age is winding down and Earth is thawing. Mammoths wander below. Wolves howl on distant ridges. Homo sapiens gather near rivers, their eyes scanning the water for fish, for danger, for reflection. Here's your odd little fact. Some ancient human settlements were so in tune with seasonal flooding that archaeologists have found homes built to float entire Neolithic villages that bobbed gently on high water, tethered like boats to the past. You crouch beside a small fire next to one of these riverbank homes. A human child squints at you, offers you a smooth stone. It's wet, shiny, probably important. You accept it with the gravitas it deserves.
Water, you realize, isn't just about biology anymore. It's culture now. People track the stars to predict floods. They dig irrigation canals. They gather in delta cities, worship river gods, trade along winding estuaries. The Nile, the Yangtze, the Tigris and Euphrates. These aren't just water sources, they're civilizations. You walk through one of those early cities' sandals, splashing in the muddy alleys after a morning rain. Pots sit beneath eaves to collect runoff. Wells are dug into the earth. Aqueducts carry water to fountains. Public baths, royal gardens. And everywhere, people are still arguing over who controls it. Scientists still debate how much of early agriculture and empire building was made possible by hydraulic engineering, the management of water on a large scale. But one thing is certain: where water flows, people follow. You pause beside a reed-filled canal and smile. You've seen microbes form membranes. You've seen algae bloom jellyfish, hunt trilobites, scuttle mosasaurs, leap dinosaurs, fall mammals, scurry, and humans stand up straight. And the one constant, that shimmer, that flow, that sound of water going somewhere new. You look up. Clouds are gathering. A soft drizzle begins enough to make the stone streets slick and make everyone walk faster. You do too, pulling a cloak around you that wasn't there a second ago. The rain is modern now. Same chemistry, but it feels older somehow. Wiser. You reach the mouth of a wide river, standing beside a dock where boats are tied off with braided rope. The sea stretches out ahead, misty on the horizon. The same sea that was once only vapor, then comet-born, then microbial soup, then predators' playground. Now it's a highway. You step aboard a small wooden vessel and untie the rope. The river takes you without argument. Drifting now, you pass the Ice Age's final retreat, watch the glaciers pull back into the poles, and see the warming earth bloom with grasses and flowering trees. Migrations begin. Species spread. Human languages evolve like ripples. And in each new settlement, there is a well or a spring or a flood story passed down like a treasure. You close your eyes as the boat rocks gently, because in all this movement across time, biology and culture, water has never lost its rhythm. You just had to listen. You're drifting now, not just downriver, but through centuries. Civilizations rise like floodwaters, shimmer for a moment in the sun, then drain away. But water remains, always flowing, always adjusting, always the quiet architect behind human progress. You open your eyes in the middle of a bustling city, but not ancient this time. Modern, concrete, steel, glass, and beneath it all, a plumbing system so vast, so woven into daily life, you barely notice it's there, until you start listening. Pipes hum beneath your feet. Faucets drip. Radiators clink. A sprinkler sputters to life in a distant park. Water isn't just outside now. It's engineered, pressurized, controlled. Here's your major science fact. The rise of modern water infrastructure, aqueducts, filtration systems, sewage pumps, transformed health and hygiene.
In cities, especially safe water distribution and waste removal, reduced disease, improved agriculture, and shaped everything from population density to industrial expansion. You duck into a quiet alley behind a grocery store. There's a dripping tap, a metal grate, a patch of weeds fighting for life in the cement. Nothing about this looks historic. But it is. Because clean water is the foundation of everything we consider modern. You wander into an apartment building and run your hand along the wall. Behind it, pipes curve like veins. Cold water from reservoirs, hot water from heaters. All of it on demand. Magic. You think back to the child offering you a shiny river stone, and now here you are flushing toilets, washing machines, fire hydrants, sprinkler systems, desalination, plants, water towers, storm drains, all of it layered, invisible, intimate. And here's your odd fact of the night. There are cities where more water leaks out of the pipes than actually reaches the taps.
Some urban systems lose up to 40% of their treated water. Silent, continuous ghost rivers under our streets. You emerge onto a busy avenue and watch the people stream past. Coffee cups in hand, showers behind them, gardens watered, pools filled. Everything scrubbed, sanitized, and softened. And most of them never thinking about it. Water has become so reliable, so ever-present, that it's almost invisible. Until it's not. You cross into the outskirts. There on the edge of the city, things shift. A rusty water truck fills up jugs for a waiting crowd. Children laugh near a trickling hose. Buckets are precious. Conversations are short. This is also modern water. Scientists still debate the long-term sustainability of global water systems. Groundwater depletion, river diversion, aquifer collapse. These are slow emergencies unfolding over decades. Some areas are drowning in excess. Others are drying from underneath. You hop a bus and head inland, where irrigation pipes stretch across vast farms like steel spiderwebs. Fields of green, kept alive by pumps that whisper at night, drawing water from aquifers thousands of years old. In your hands, an orange. It took nearly 50 litres of water to grow. You bite into it slowly. Because the more comfortable our lives have become, the thirstier we've gotten. Agriculture, energy industry, sanitation. Every modern convenience carries a silent, shimmering price tag. You reach a dam just before sunset. It's a wall of poured concrete, thick and proud, holding back a shimmering reservoir. The water looks peaceful, but you know better. It's tamed, not calm. You walk along the edge, feeling the hum of turbines below. Hydroelectric power. Drinking water. Flood control. But also disrupted fish migrations, sunken valleys, displaced communities. Water obeys the dam, but it doesn't forget. Below it, the river is lean. Controlled. Tracked by satellites.
Regulated by law.
And yet, it still runs. You scoop a handful from the surface and let it slip through your fingers. It's the same water that once bathed trilobites, dinosaurs, Ice Age wolves, and Roman aqueducts. It's the same that fell on your shoulder as steam from a Precambrian sky. The same molecules just looping. You sit on the dam wall as the sun dips low, bathing the water in orange. The hum of the city fades. The stars begin their slow reveal. And you wonder, if the pipes stopped, if the taps ran dry, if the system blinked out for even a day, would we know how to find it again? Water has shaped our biology, our settlements, our science, our stories. And yet we forget, because it's good at disappearing, at being dependable, at letting us believe we're in charge. But we're not. We're hosted politely by a guest that predates our bones. You lie down on the warm concrete eyes fixed on the stars. There's one more chapter ahead, but for now, let the water hum in the walls. You wake up beside a desert. a vast plain of cracked earth, sun-scorched and shimmering in the distance. The wind carries a dry whisper like the memory of a river. And you realize this place wasn't always like this. You walk a few steps and your foot sinks into fine dust. There are fossilized ripple marks beneath its stone waves, etched in time proof that water once danced here. Maybe it still does deep below, hidden in aquifers, waiting for a chance to rise again. You've arrived at the present. And it's complicated. Here's your major science fact. Only about 2.5% of Earth's water is fresh water, and most of that is locked in glaciers or buried underground. Less than 1% is accessible for human use. As population consumption and climate stress grow, this delicate balance becomes a global concern. You look up. In one part of the world, rain hammers rooftops, floods subways, and sends rivers bursting over levees. In another, the air is too dry to breathe. Crops wither, wells drop. A child walks miles for a single plastic jug. And everywhere people argue over who gets to turn the tap. You walk through a modern city again, taller, louder now. Screens glow with news updates, floods in Asia, droughts in California, rising sea levels swallowing homes. The same stories on loop, ancient struggles dressed in silicon. But beneath the noise, there are whispers of hope. You pass scientists in lab coats, huddled around desalination filters and atmospheric water generators. Farmers tweaking drip irrigation. Engineers rebuilding floodplains. Kids planting trees. Activists marching for rivers with no voice of their own. Here's your odd fact. There's a project in Chile that harvests fog, huge mesh nets catching mist from the air, turning it into clean drinking water for entire communities. Sometimes the best solutions don't fight water. They listen. You stroll into a school where a globe spins lazily on a desk. A child dips a paintbrush in a jar of clear water and adds blue to the ocean. She doesn't look up. She just paints the earth whole again. And you think about how every human civilization began near a river. How every myth has a flood. How every heartbeat is a pulse of water echoing through muscle and time. Scientists still debate how much of the coming crisis is avoidable, whether our habits can shift fast enough, whether the warming will slow, whether water will remain a gift or become a reckoning. You step outside as rain begins to fall, not too heavy, not too late. It splashes on your skin, and for a second you close your eyes, because it feels familiar. The same rain that fell on the first microbes, the same that filled ancient seas, the same that mingled with comet dust, glacier melt, and dinosaur footprints. It falls on you now with no judgment, just persistence. You look up and speak softly, not to the sky, not to the ocean, but to time itself. Thank you. Because if there's one thread that's never snapped, one presence that shaped every living breath, every leaf and leap and civilization, it's this. The story of water is the story of everything. And you've been floating in it all along. You lie still now, wrapped in the hush of midnight, the sound of water fading to a distant murmur. Not gone, just quieter. The story has slowed. The river of time has curved gently into a pool, a still surface, holding every reflection from the journey behind you. From the cosmic dust of the early solar system to the first droplets condensing in an atmosphere barely old enough to know what clouds were. From bacteria pulsing through ancient seas to fish, to fins, to footprints, from thirst to worship, from survival to plumbing. All of it, every living chapter, written in the language of water. And tonight, you heard it speak.
Maybe now when you wash your face,
You'll think of ancient rivers. Maybe your morning cup of tea will echo with rain that once fell on dinosaur skin. Maybe the sound of the shower will remind you that the world is older than it looks and still soft in places. You are mostly water. You are built from oceans you'll never see. You carry molecules that rained on kings and fell through caves and once danced across a comet's tail. You are not separate from it. You are a continuation. So let it lull you now, the way the tide always returns, the way the mist waits in the trees, the way the planet, against all odds, keeps turning in the dark, making room for another drop, another ripple, another story. Close your eyes, let the last wave pass, and sleep in the story that made you. End of script. Good night.